Alright, Algebra 2, welcome to your first video of 2015. I hope you had a restful vacation. And now, let's get back to do some math. Yay. Alright, we're trying to find what the factors are of our sum and difference of cubes. Our sum and difference of cubes are just addition or subtraction between two perfect cubes. Maybe the first question you asked yourself is, what is a perfect cube? A perfect cube is any number that I can multiply by itself twice. Okay, so 2 times 2 times 2 equals 8. 8 is a perfect cube. The cube root of 8 is 2. Just like the square root of 4 is 2. Okay, square root, we multiply it by itself once. Cube root, it's a number that we multiply by itself twice. Okay? So the 3 times 3 times 3 is 27. That's a perfect cube. 4 times 4 times 4, 64. That's a perfect cube. 5 cubed is 125. There's a perfect cube. So again, if I was to go backwards, the cube root of 125 is 5. The cube root of 64 is 4. The cube root of 27 is 3. Alright, and so on and so forth. So, you will need to know some of those perfect cubes. You'll need to know how to find them, if nothing else. Most calculators can help you with that a little bit, but hopefully you get good enough that you can do it without even using a calculator, that you just know them. It's always helpful when you can just recall them. Alright, so let's talk about how we find the sum and difference of cubes. There's two different ones that we have to talk about. Let's talk about sum first. So a cubed plus b cubed. So for sum a and sum b, it can be any numbers in the world. They don't have to be the same number. The cubed versions of those, if we want to factor this polynomial, then we end up with a plus b, okay, times a squared minus a times b plus b squared. Alright, this is the factored form. Okay, let's talk about the other one. A cubed minus b cubed equals, again, the first term is pretty straightforward, a minus b. Okay, just like a cubed plus b cubed was a plus b. A cubed minus b cubed is a minus b times a squared plus a times b plus b squared. Okay, not too much in there. Alright, not too much in there, and it's pretty straightforward. And I'd love to prove this to you, but unfortunately, we're getting pressed with time. So let's move forward. There's a nice little acronym I like to use to help you remember the second step. The first step, hopefully, you can get on your own. It's the second step I want to help you remember. The acronym is SOPPS. It's SOPPS, which makes perfect sense. Okay, SOPPS is a word. Alright, and what does it stand for? It stands for square, stands for opposite sign. I'd write this down. Stands for product, stands for plus, and stands for square. So square the second term. Okay? Easy enough. So let's use SOPPS right now with one of the examples we have here. So x cubed minus 8. I know that 8 is a perfect cube, and the cube root of 8 is 2, so it becomes x minus 2. Okay, remember that first term, first binomial is always pretty straightforward. And now for the next one, let's use SOPPS. So I square the first term. The first term is x, so x squared. I want the opposite sign. It's negative, so I want plus. Then the product of 2 and x, which is 2x. And then a plus sign, and then square the second term. 2 squared is 4. And we have it. That's your answer. Right there. Okay? So try this one out real quick using our method. Let's see if we get the right answer. Go ahead and hit pause. Alright, so here's what I got right here. Sorry, I just moved the page on you a little bit. Here's what I got right here. Y plus 3, that's the cube root of 27 is 3. The cube root of y cubed is y. And then y squared minus 3y plus 9. Down here, we have a little bit of a different problem. We have 8z cubed minus 216. Well, the cube root of 216 is 6. And the cube root of 8z cubed is 2z. Sign stays the same. And then I just go through with my SOPPS. So square the first term, that's 4z squared, don't forget about that. Opposite sign, and then the product, so 12z, 6 times 2z is 12z, plus, and square the second term, 36. It does not change a thing, we just keep doing the same thing. Alright, we'll work with this more tomorrow, but right now let's move on to the other type of factoring I want to go over with you real quick, which is by grouping. Okay? And let's all remember that we're having fun. Alright? Grouping can get, like I said earlier today, in most of the classes, you're basically already doing it when we do the AC method. You are factoring by grouping. We're just going to give it an official title and look at it in special cases where 4 terms or more are there. So remember, with factor by grouping, the first thing that we need to do is divide it in 2. Cut it in half. And then find the greatest common factor in both of them. This is 2x squared, and I'm left with just an x plus 1. And over here, my greatest common factor is 3, and I'm left with just x plus 1. And just like we talked about earlier today, the important thing when we're factoring by grouping is that these are the same. If these are the same, then we have success. Yay. Now we get to write the final answer. Final answer is 2x squared plus 3 and x plus 1, using our parentheses correctly. And there, that is factor by grouping. Okay, so try this one out right now. There's a negative in there. Be careful of that. Hit pause and I'll try it out with you, and then we'll come back. Okay, so there's my answer. 2x squared minus 1 and x plus 2. Remember, you can always factor out a negative 1, and when both of these are negative, take out that negative 1, we end up with the same thing, x plus 2 and x plus 2, which means success. We can work through this. Now what about this nasty one down here below? I love